This is our second and last video for our 10.4 notes. It's just the second half of this section, still dealing with different inscribed angles. So what this is saying is if two inscribed angles of a circle intercept the same arc, then of course the angles have to be congruent. So let's look at this angle, inscribed angle here, ACB. I see that angle, and again, let me write this in here. I see that angle ACB is intercepting the arc AB. So let's just, hold on, let me just insert that for you guys. So I see a measure angle ACB is intercepting arc AB. And I also see that angle ADB is intercepting the arc AB. So because they're both intercepting the same arc, using our theories we learned in the other lesson, they have to be equal to each other because they're both going to be cutting whatever that arc value length is in half in order to figure out their measure. I know they're both intercepting the same arc because if you were to actually draw through the angles and extend them, AB is an endpoint matching up with side AC, and B is an endpoint lying on side BC. Same thing. A is an endpoint on AD, and B is an endpoint on DB. So they're both enclosing this one section of the circle, so I can conclude that those angle measures, so if we wanted to just be simple, angle C and angle D are equal to each other. So in this example here, I'm showing how that actually works. So I see that angle E is 75 degrees, and that angle itself is intercepting the arc GH, because if I was to draw out this angle, the endpoints are on GH. If I want to find out the angle F, I see that it's also intercepting the same arc of GH, so I know that angle F has to also equal 75 degrees because they're both intercepting the same area of the circle. If I'm looking at part B, I'm seeing that this angle here, let's call it A, is intercepting this small section of the circle. So again, we're just drawing out where that triangle or that angle is, and we see that it's only covering this section of the circle when both sides would extend through it. And I also see that this other smaller angle, we can call it B, is it's extending and intercepting the same area of the circle. Therefore, I know that angle A and angle B are equal to each other, so I can set up these two expressions being equal to each other. And if we just want to find out what the value of x is, we just set them equal and start to solve. So I would probably subtract 2x on both sides and have 11 is equal to 2x minus 3. Then we would add 3 on both sides, and I would have 14 is equal to 2x. Therefore, x is equal to 7. Just be careful on your homework. It might actually ask you to find the angle measure, so you would have to plug in your variable amount back in. The last part of this section talks about what if different shapes were being constructed within a circle. So the first rule is if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. So angle B would be the right angle and AC would be the hypotenuse, since that goes through the center of the circle and extends to either side of the circle. I know that angle B is the right angle because the hypotenuse has to be directly across from the right angle. And then the next part of the sentence is just saying that if it was flipped around, that if a triangle was drawn on the inside and I knew that AC was the hypotenuse or the diameter, therefore the opposite angles would be 90 degrees and all that stuff. So it's really just if a right triangle is drawn within a circle, I know that the hypotenuse is the same as the diameter and that the angle that is actually the right angle is directly across from the hypotenuse. The quadrilateral rule is, remember, a quadrilateral is a four-sided shape, is that if a quadrilateral is drawn within a circle, the opposite angles have to be supplementary. So that means angle E plus angle G, so let's just do E plus G has to equal 180 degrees, and that's what supplementary means. And the same thing for F, angle F plus angle D also has to equal 180 degrees. And please draw in the angle signs. I'm just being lazy and not inserting those values from the equation tab in my Word document. So some of the examples on how to solve these different questions that I gave you. Let's say we're looking at this right triangle here. You're assuming that it's a right triangle because we drew one within the diagram. The longest side is the hypotenuse, and it runs through the center, so we know it's the diameter. So therefore, AB is the hypotenuse. The angle across from that is angle C. So I know that angle C has to equal 90 degrees. And if I want the value of x, I know 2x has to be equal to 90 degrees, or x is just equal to 45 degrees. In part B, if I want to find the values of the variables, I know that opposite angles are supplementary. So I know that 80 degrees is angle F, and the angle opposite that is D, which is represented by the variable Z, and I know they both have to equal 180 degrees. So if we just solve for the variable Z, I know that has to be 100 degrees. And then if we were solving for the next set of variables, I see that E is 120 degrees, and the angle opposite that is Y, and they also have to add up to 180. Therefore, Y is equal to 60 degrees. Part C is just like part A. I see that this right triangle is drawn within the circle. I see that BA is the diameter and also the hypotenuse. So therefore, the angle across from BA is C, and I know that has to be 90 degrees. So I set 3x equal to 90, or x is just equal to 30 degrees. Let's actually move that back a little bit. We'll just leave that there. The last section is the same idea, but I'm just going to leave this one since it's just like part B, and I'm going to jump to E. So if I'm looking at part E, whoa. Why is it not letting me write next to it? That's so strange. For part E, what I would be doing is setting up equal to each other. We have a four-sided shape here. It looks somewhat like a kite is drawn within the circle, and opposite angles are equal to 180 degrees. So do not set these equal to each other. They also don't look like they'd be the same measure, but I am allowed to say 3x minus 8 plus 5x plus 2 is equal to 180 degrees. Again, do not set them equal to each other. We are saying that they add up to 180 degrees together. So then we want to combine some like terms, and we'd have 8x minus 6 is equal to 180. So I hope everyone's somewhat following along with what I'm doing here. And then we would have to add 6 to both sides. So we would have then 8x is equal to 186. And then we solve for x, and we are going to get x is equal to, that's not going to go in nicely, 23 something, I believe, 23.25. So again, 3x minus 8 plus 5x plus 2, so 3 plus 5, 8x, so on and so forth, and you're just solving for the variable.